All right, this is the last part of chapter 5. Ray. And thankfully, this is something you guys already aware of. We discussed the exact most similar topic, or I should say, exactly same topic in chapter 2, at the end of chapter 2. And again, we are reviewing here just to get familiarize ourselves. Um, let's see. This is, if you guys remember, this is exact slide I used in chapter 2 to introduce the topic called molar mass. Remember, I'm using the word molar mass, not the molecular mass. Molecular mass, what we just discussed 2 sections ago, is the mass of an atom in atomic mass units. But molar mass is mass of an atom in grams, mass of 1 mole of atom in grams. Here we're just going to review how we come up to the definitions of molar mass. If you see here, first we are going to learn about a mole, okay? Because it is what is going to lead to molar mass. A mole is defined as amount of, particles, amount of substance that are present in 12 grams of carbon-12 sample. Like you collect 12 grams of carbon-12 samples and you try to identify how many of carbon-12 atoms in it. When we identify it, we find that there are total of 6.022 times 10 to the power of 23 atoms. See how many? There are so many in 12 grams. There are so many carbon 12s in 12 grams because atoms are so light. Atoms has so minute mass. If you guys remember, one atomic mass unit of a proton or neutron is going to weigh only 1.6 times 10 to the power of negative 24 grams, which means it is so small. Because it is so small, in 12 grams you have these many, more than quadrillion times of atoms. So because of that, we just use mole as a word to calculate the masses of compounds. So now mole is something that we are going to use. This is for atoms. And in the next slide, I'm going to move on to what is the molar masses. Because we know that, when you say moles, we are trying to calculate mass in grams, because that's what comes up to be, right? 12 grams of carbon-12 contains 1 mole of atoms. Now, based on that definition, I'm going to define a molar mass of a substance is the mass in grams of 1 mole of substance. What is the molar mass is, again, is the mass of the substance in grams of 1 mole. Okay, what does that mean is you already know what is the mass of, let's say, 1 carbon atom, which is 12.01 atomic mass units. But what is the mass of 1 mole of 12 carbon atoms? 1 mole of carbon atoms is the same magnitude as the atomic weight, but in grams as a unit. So if 1 carbon atom is going to weigh 12.01 atomic mass units, 1 mole of carbon atom is going to weigh 12.01 grams. And it is applicable to any other element out there. Like 1 oxygen atom is going to weigh 16.0 atomic mass units. So 1 mole of oxygen atoms is going to weigh 16.00 grams. Let's say 1 hydrogen atom is going to weigh 1.008 atomic mass units, but 1 mole of hydrogen atom is going to weigh 1.008 grams. Same numerically equal number as atomic weight, but units are changed to grams. That's what molar mass is. How do you use the molar mass? You use the molar mass to identify the mass of a compound in grams. Okay, it is same as molecular mass, but the units are in grams. So 1 mole of H2O has 2 hydrogen atoms, so 1.008 grams, and it has it has only 1 oxygen atom, so 16.00 grams. So the mass of 1 mole of water is 18.02 grams. And let's look at this problem, NaCl. NaCl contains sodium and chlorine. So in this formula of NaCl, you have one chlorine with 35.45 grams, 1 mole of chlorine, and 1 mole of sodium weighs 22.99 grams. So together, 1 mole of sodium chloride is going to weigh 58.44 grams. This is how you would calculate molar mass of any compound. Again, it is the same magnitude as the atomic weight, because the way it is defined is helping us do that. But the units are in grams. All right. So this is just some caution slide. It is just telling you that pay attention to what we are trying to say in words. For example, if you're trying to refer to oxygen, for example, exists in many different forms in many different compounds. What if I just say how many moles of oxygen react with 2 moles of hydrogen to produce water? Okay, see that question, how complicated it sounds. How many moles of oxygen reacts with 2 moles of hydrogen to produce water? So you need a O2 to react with 2 moles of hydrogen water, 2 moles of hydrogen. Let's see. Let me check if the question is right. How many moles of oxygen react with 2 moles of hydrogen to produce water? Let me pause and make that question more technically correct. I made a little change to that question, so it is technically more correct. Let's look at the question again. The question says that how many moles of oxygen react with 2 moles of hydrogen molecules? I added the word molecules because hydrogen molecule is H2. Okay, so we already know that water is this, right? H2O. It's saying if you have 2 molecules of H2, 2 moles of H2 molecules, how many moles of oxygen you need? You need 1 mole of oxygen that is currently balanced as 2H2O. So you need 1 O2. And when you say O2, you're including 2 oxygens. So molar mass is going to change it to 32. Let's see next question. How many moles of oxygen are there in 1 mole of water? What is 1 mole of water looks like? H2O. In 1 mole of water, you have 1 mole of oxygen atom, not O2. So just oxygen single atom. So its molar mass in oxygen, its molar mass in water is only 16 grams. And let's look at this statement. Air is approximately 21% oxygen. Okay, just using the word oxygen, but we're not saying how many of them. We already know by familiarity that oxygen air molecule exists as O2. So O2 has molar mass of 32. And many organic molecules, many organic compounds contain oxygen. It could be most likely in the form of single oxygen. So in that case, it is going to look like just 16 grams. Again, it's just saying that you need to be careful knowing what you are reading, making sure that you know what is the end chemical formula is from the words, just to be careful. If you guys remember, we practiced on this table in chapter 2, how to convert one type of unit to another type of unit. I'm just giving here so because you all liked it and you have, let's say, memory about what we just discussed. So you will have easy time when I discuss a couple of problems related to this topic. Let's look into this problem. Let's see where we started is we started at how to convert the amount in grams to number of moles and number of atoms or molecules. How do you convert amount in grams of iron to number of moles? This is what we are going to use, right? You're going to multiply our given unit with the conversion factor that contains given unit in the denominator. So iron has molar mass of, so you're going to use molar mass conversion factor for 1 mole of iron. How many grams you have is you have 55.85 grams. So you can cancel out iron to end up with new moles of iron, which is 5.03. If you have 5.03 moles, how do you identify how many number of iron atoms are present? In this case, you're going to use the Avogadro's conversion factor, which has Avogadro number and 1 mole. In this case, you want to use the mole in the denominator so that you could cancel out the unwanted units to end up with your answer of how many molecules of iron present in there. How do you convert moles of iodine molecule, I2, to amount in grams and amount in molecules? Okay, let's find out how many grams are in there. To convert moles to grams, again, you need to use the molar mass conversion factor. With 1 mole is equal to how much of 1 mole of I2 is going to weigh. 1 mole of I2 is going to weigh 253.8 grams of iodine. So now if you have 1 mole in the denominator, you can cancel out the moles and find out that it is going to weigh 1780 grams. And let's identify how to identify the number of molecules of I2 in 7 moles of I2. Again, you're going to use Avogadro's conversion factor with the moles at the bottom so that you can cancel out the moles and end up with the molecules of iodine in 7 moles of iodine. What if you have given the molecules of sulfur and ask you to identify number of moles and grams? You cannot directly go from here to here. That's not possible. Please do not attempt it. To identify amount of grams, first you need to identify how many number of moles of sulfur is present in the given number of molecules. For that, you're going to use the conversion factor, but this time you're going to have the molecules in the denominator so that you could cancel out the units to end up with moles as your final answer. Once you have the moles, you can identify grams if you multiply that the molar mass of sulfur as your conversion factor. So 1 mole of sulfur 8 is going to weigh 256.3 grams. So if you have the moles in the denominator, you can cancel out the units to end up with your final amount in grams of sulfur 8 as 96 grams. Right? This is what you need to do. And what I have here for the rest of the lecture is I have a couple of problems for you and I want you to solve them and make me proud. I want you to pause the video and solve these. Feel good about yourself and make me proud virtually. Let's see. The question is asking us to determine the number of moles of CO2 in 10 grams of carbon dioxide. Okay. So it gave you the mass of CO2, but it is asking you to identify moles. Mass to moles is one-step conversion factor, like we saw it in the previous chart. You're going to have molar mass conversion factor and multiply with the molar mass conversion factor to end up with how many moles are present. Molar mass of CO2 is 44. So you would have it in the denominator, so you can cancel the units of grams. So 0.2278 moles of CO2. I have still 4 significant figures because given data has 4 significant figures. Problem B is asking in 0.905 moles of sodium chloride, let's see, determine the mass of sodium chloride. So you have moles, but you are asked to identify mass in grams. Again, you have to use the molar mass conversion factor. Again, to use the molar mass conversion factor, you need to know 1 mole of mass of that particular compound. NaCl is going to weigh 58.44 grams. So you're going to set up the equation to have the moles in the denominator. So you cancel the moles to end up with amount of NaCl in grams. This is how you would solve for this problem. This has to be our second nature in easily solving these problems, so that we can do much more advanced things if you are really good at it. And I want you to get good at it really soon. Now let's work on a couple more problems. Determine the number of water molecules and the number of hydrogen and oxygen atoms in 3.26 grams of water. Looks like it is a bit more challenging, right? I would agree, but we can solve it. We had enough practice and we know the concept, okay? Let's work on that first problem before going to the second one. So it is asking us to determine the number of water molecules, okay? That is one part in 3.26 grams. Number of molecules from grams is not a direct step. Remember, you cannot convert the grams to molecules or molecules to grams in one step. First, you need to identify moles in between, then you can solve it in the second step. So your goal is to identify how many moles of water is present in 3.26 grams of water. Then you can identify how many molecules are present in those many respective moles. Then we worry about individual hydrogen and oxygen atoms. So let's work on that. So first, let's identify how many molecules of water is present in 3.26 grams. You need to multiply your 3.26 grams with the molar mass conversion factor of 1 mole. So you can cancel out these grams and grams. So you would, left with moles of water here. And you can do it in 2 different steps, or you can keep on multiplying until you get the molecules. And if you do it like this, you need to use the Avogadro's number as a conversion factor to cancel out the units, and you would end up with your answer in molecules. Okay. The question is not just asking how many number of molecules of water are present. It is asking how many number of hydrogen and oxygen elements are present. So in 1.09 10 to the power of 23 H2O molecules, how many hydrogen atoms are present? For that, you need to know how many hydrogen atoms are present in each water molecule. There are 2 hydrogen atoms and 1 oxygen atom. Okay, so we are going to make conversion factor for that. So in these many water molecules, you have for each 1 water molecule, you have 2 hydrogen atoms. That's your conversion factor. This is your conversion factor that we made from this ratio. Okay, so you have these many hydrogen atoms. So for these many water molecules, the ratio of oxygen atom to water is 1:1. So you have same number of water molecules as the oxygen atoms. Okay, let's work on last problem. Determine the mass of 7.92 times 10 to the power of 19 molecules of carbon dioxide. Okay, so your given molecules ask you to identify the mass. Again, it is not done in one step. It cannot be done in one step. It has to be done in 2 steps. So the plan is to convert to the moles first, then to the mass later. So you're going to convert from molecules to moles. You're going to use the Avogadro's conversion factor. Then you're going to use the molar mass conversion factor to end up with the mass in grams. So to do that, you are going to use the Avogadro's conversion factor to cancel the units here. And from moles to mass, you're going to use the molar mass conversion factor to end up with your answer in grams like this. Okay. Please control your temptations whenever you are asked to convert from molecules to mass or mass to molecules. Do not try to get anything in shortcut, because there is no shortcut to convert mass to molecules or molecules to mass. Okay, so this is all for chapter 5. There is just one topic that I'm not wild about, that is I'm not discussing, which is determination of empirical formula using the molecular formula and percent composition. I guess it is just more distraction than adding value to it at this stage. So we don't really discuss these topics, so don't worry about it if you see it. So skipping it. And here is the summary of the chapter. I hope I did a good job in explaining all of these topics. I hope you are going to master these topics. There are so many easy topics and a few challenging topics in here. I can, see them again here. Those can be a bit challenging to name, but they are not going to bother you a lot. um, Let me highlight what are most important on this chapter is molar mass, yes, and restart symbols, I need you to know that, and lattice energy, very much needed, and how to name compound nomenclature, I really need you to know that, and covalent bonding for next couple chapters, I need you to know that, and the molecular compound names, I need you to know that. Those are must know topics. Everything else also you need to know, but they were highly important. Okay. That's all for chapter 5. I hope you guys had a good time learning these topics. I certainly enjoy teaching these topics to you. I will sign off for now and see you guys on chapter 6.